Let's graph another rational function. This time we have g of x equals 4x minus 2 over x plus 1. To start out, we want to make sure the function is in lowest terms. It is. We could go ahead and factor a 2 in the numerator, although it won't make much difference as we're working through the problem. In the first step, we want to find the vertical asymptotes, and after that the horizontal asymptotes. And remember, we already did that for this function in a previous video. So we'll go through it again here. Step 1 is a vertical asymptote. We just need to set the denominator equal to 0. X plus 1 equals 0 means that x equals negative 1 is the vertical asymptote. And then step 2 is the horizontal asymptote. Look at the degree of the numerator is 1. It's equal to the degree of the denominator, also 1. And so we take the leading coefficients. 4 divided by 1 is 4. We have a horizontal asymptote at 4 over 1, or y equals 4. In the next step, we want to find a y-intercept. So we're going to set here, let's make that a little better. Let's find a y-intercept. Let's set x equal to 0, and we'll have, let's see, 0, 4 times 0 minus 2 is negative 2 over 0 plus 1 is 1, negative 2 over 1, or negative 2. So the y-intercept is at 0, negative 2. The next thing to do is to find the x-intercept. Remember, we set the numerator equal to 0 this time. We have 4x minus 2 equals 0, and we solve for x. So x equals, add 2 to both sides and divide by 4, and we get x equals 2 over 4, or 1/2. We can write that as an ordered pair, 1/2, comma, 0. Step 5. Does the graph cross the horizontal asymptote? Does g of x intersect the horizontal asymptote? And so remember how we did this? We said we want to solve the equation where we set the function equal to the horizontal asymptote. So the function is 4x minus 2 and divided by x plus 1, and the horizontal asymptote is at 4. So we're asking when is the y value 4 for this function? When is the y value 4 for this function? So solve for x. So we can clear out the fractions. We can multiply by x plus 1 on both sides. The x plus 1's cancel on the left side, and we're left with 4x minus 2. On the right side, we can distribute and get 4x plus 4. And then to solve for x, we would group the x's on one side, and sure enough, they're going to cancel each other out on both sides. So we have negative 2 equals 4, which is a contradiction. That's never true, and so there's no solution. And so that means that g of x does not cross the horizontal asymptote. Okay, let's go ahead and make a sign diagram. Let's see here. Sign diagram starts with 4 columns. It starts with a column for interval, and then test value, and then we want the sign of g of x, which is 4x minus 2 over x plus 1. We could use the factored form with the 2 out front, but that's not going to make much difference. And of course the question we're trying to ask is g of x above or below the x-axis? Okay, do you remember how we make the intervals? We want to look at the x-intercepts and also at the vertical asymptotes. So there's only one x-intercept at 1/2, and there's only one vertical asymptote at -1. So when we start from -infinity, we go up to the first number, the -1, and then we can continue on the other side of that up to 1/2, and then from 1/2 all the way to infinity. Test values, -2, 0, and 1 would work fine. And then we can check the sign. Plug -2 into the numerator, you have -8 minus 2 is a negative number. In the denominator, you have -2 plus 1, which is another negative. And so that a negative divided by a negative is a positive. That means we're going to start out above the x-axis. And then we can plug in 0. 4 times 0 minus 2 is -2. In the denominator, 0 plus 1 is +1. Negative divided by a positive is a negative. So we're below the x-axis. And then we have, if we plug in 1, we get 4 times 1 minus 2 is a positive, and 1 plus 1 is also a positive, and so we wind up with positive. And we're back above the x-axis. Okay, we can put all that together to make a graph. Maybe we'll, I don't know the best place to make this graph. Maybe we'll just come right over here. So step 7, let's go ahead and sketch the graph. Let's start with axes. Let's label them. Let's label the origin. And then let's go back and see where to begin. Let's start with the vertical asymptotes. We have a vertical asymptote at x is -1 and a horizontal asymptote at y is 4. Vertical asymptote at -1. Horizontal asymptote. I don't want that horizontal asymptote to go too high, so I'm just going to count by 2's there. And then I can draw my horizontal asymptote there. And I can draw my vertical asymptote here. And I want to make sure that I label them. Okay, does that look all right? 2 asymptotes. We have a y-intercept at -2 and an x-intercept at 1/2. A y-intercept at -2 and an x-intercept at 1/2. Okay, so we've plotted those 2 points. Does the graph cross the horizontal asymptote? No, it does not. And so that's all the information we have we'll use the sign diagram to finish this off. Okay, so here I like to change pen color when I'm drawing in the graph. It doesn't really matter what color it is. Let's start from the left end of the graph and let's work our way over. You know that at the left and the right ends of the graph, we have to approach the horizontal asymptote. There's only two ways to do that, from above or from below. Which is it? Usually when I ask this question in class, students get the answer right for the wrong reason. So is the graph above or below the horizontal asymptote? They say above, and the reason is because they're looking at the sign diagram that says above. But that's not the reason, right? Above in the sign diagram means above the x-axis. Both of these are above the x-axis. The x-axis is way down here. So we have to think a little harder about this. We're really not sure at this point which it is. So let's keep going. Let's go over to the vertical asymptote and let's draw the two options there. We can either point up toward positive infinity or down toward negative infinity. Which is it? Well, now the above really does tell us the answer. Since we're above the x-axis to the left of -1, we have to be up here and not down here. This is below. These are negative y values down here. So we know this arrow is correct. How do we know that this arrow is correct? We know by step 5. We know that the function never crosses its horizontal asymptote. So if this were the answer, right, if this part out here were correct, then we would have to have a point where we cross the horizontal asymptote to get to this arrow up here. And we don't have that. And so all of this is, well, most of this is junk, and we can erase it. And we can start fresh here. So bear with me here as I work through the technology. So what we said then is that we've got to be above so that we can connect up with the arrow pointing up on the left side of the vertical asymptote. So there's how the graph starts. On the other side of the vertical asymptote, we have two choices. We can either shoot up or shoot down. This is a little more straightforward. Above the x-axis or below the x-axis. To the right of -1 is this next second interval. We're below the x-axis. So we can erase that. And then we can just continue this curve through the y-intercept and the x-intercept. And then we can approach the horizontal asymptote. Two ways to do that. We could either go cross over and then be above, or we could stay below. Which is it? The sign diagram tells us we're above the x-axis. Of course we're above the x-axis because we're near 4, right? Are we above 4 or below 4? We know that we're below 4 because we never cross, because we know we don't cross the horizontal asymptote. So we can erase this business here, and let me try to clean this up just a little bit. So let's draw the horizontal asymptote back in, and then let me show you the graph leveling out to the horizontal asymptote. And there's our graph.